And hello, everyone, and welcome to the RSA panel where we're discussing how to do the safety dance. So it is my super pleasure, let's be clear, to work with and be able to introduce to you our panelists, as well as introduce to you, some of you, possibly, the Confidential Computing Consortium. So, and also more broadly, confidential computing. So let's talk first about confidential computing as a definition. So more than 30 different companies around confidential computing and having an interest in confidential computing have gone ahead and built a definition for this. So the groups that participated included CSP and silicon vendors and cloud vendors and hardware manufacturers, service companies, et cetera. And they spent more than 6 months defining what confidential computing is in order to build for our industry a good, solid standard to have our future well and sufficiently supported with confidence and confidentiality. So what is this actual definition? And what, broadly speaking, confidential computing is the protection of data in use. This is the big differentiator. In use, using hardware-based trusted execution environments. And now you ask, what is a TEE? What is a trusted execution environment? It's a hardware-based TEE using hardware-backed techniques to provide increased security guarantees for the execution of code and protection of data within that environment. Again, data in use. So now that we have a basic definition, thanks to the Confidential Computing Consortium, of what confidential computing is, we now get to talk about how this can help you as end users and customers and how this really moves our industry forward. So let me do quick introductions for our panelists. Today, we're going to get to talk with Ava Black, who works at Microsoft, working in the Azure Confidential Compute group. We get to speak with Nellie Porter, who works for Google, also working on confidential computing. You may see a theme here. And now we also get to speak with Mike Bursell, who is a longtime architect at Red Hat and also, oddly enough, works on confidential computing. So if they have other things they want to add in their little, in the introductions or as way of introductions, we can have them add them as we ask some questions. So let's start with, we gave the definition. Let's start with the basic question of who should care about confidential computing? Is this something everyone should be interested in? What are the use cases that are deployable today? And what role do we think open source plays in this? So let's start with Ava today. So Ava, if you have anything more to add to your introduction, and then talk about who you think should care about confidential computing.
Sure. So in addition to being involved in the Confidential Computing Consortium, I'm also involved in a couple other open source foundations. I've been around cloud computing, gosh, for a while now, I guess more than 10 years. Worked a bunch in OpenStack on hardware security. And before that, other stuff. And I think really everyone should care about digital privacy. And you might notice that theme, I really care a lot about digital privacy. And I think a lot of people today do care deeply about it, enough that several governments around the world have begun passing or looking into passing data privacy laws. And to support this, I think every company also needs to care, right? Listen to your users, especially those that handle sensitive data, personal data, or operate in regulated industries.
So Mike, I know you often have differing opinions.
We have complementary opinions.
Complementary is a great way to describe
quite often. How about that?
Yeah.
So firstly, a bit about me. I'm part of the Office of the CTO at Red Hat, Chief Security Architect. I'm also co-founder of the NARCS project, which is an open source project around confidential computing. So I think one answer to who should care about confidential computing is CISOs. CISOs should care about confidential computing, not just commercial companies, but government, charitable, healthcare, pretty much everyone, because all of those, as Ava said, have data or algorithms or workloads or programs that are sensitive and that need to be protected in some way or other. So, I mean, architects need to learn about it and the opportunities it offers, and developers should think about getting their hands dirty. But if the CISOs on the call don't understand that change it can make to the organizations that they lead or they're part of, then they're not just missing out on an important new technology, but also really, I think, to a change to how we're going to think about deploying applications and our risk profiles. And that's really important. And you also asked about open source. From my point of view, open source is vital in this because you can't trust we love open source. Yeah. If you can't trust what you're running, then how can you trust that it's been protected properly? And you can't trust it unless it's open source and you can audit it. The community can audit it. We'll probably come back to this a bit later on, but I think open source is vital in this context. Nelly.
Awesome. Nelly, yeah.
Thank you so much, Mike and Sarah. So again, adding a few words about me. I'm with Google, cloud security in Google, and all of this time I was working in confidential computing. I'm leading confidential computing efforts in Google and trying to help industry to drive interoperable technology. So all of us would be able to work together in harmony if it's ever possible. But again, who cares about confidential computing? I absolutely agree with both of you. It needs to be from CEOs, CISOs, but also, again, cloud admins, IT teams, DevOps, everybody is touching infrastructure, touching workloads, and trying to make them protected when they're running, because we all familiar with necessity of protecting data in transit and in rest, but somehow we forgot completely about the fact that we need to do something with this data. We need to index it. We need query this data. We need train on this data. And it means confidential computing here to fill this hole. One additional thing that you asked, Sarah, about use cases, and that's kind of where I'm going. So use cases, I think it's a lot of use cases. When we started and we had so many conversations with customers and users, it was kind of very limited set of, oh my God, how will protect my secrets, what I will do with my certificate, etc. But as we're moving along, there's an ability of confidential computing to cover incredibly large workloads becoming necessity. Our customers talking about, I want to bring any database from Postgres to MySQL to MongoDB. I want to protect my employees' records utilizing those databases. Or how I will do analytics, and it means Spark and Hadoop and name it. And how we'll do all of those simulation, and preferably not only on CPUs, but give me GPUs, TPUs, and the FPGAs. And it's why the Confidential Computing Consortium with all silicon industries is so critically important, because we all have the same goals, but we need to have very clear, again, requirements, what and how we will implement those goals. Mike, you're raising your hand as usual.
Yeah, Nelly,
you
touched on an important point, which I want to bring out, which is It's not just necessarily the data you're looking after. You sometimes want to protect the programs themselves. Mm-hmm. If you think about, sort of AI or ML, those programs themselves, or trading applications, or pharma or voting applications, all of these things. In fact, sometimes it's not the data is sometimes even subsidiary to the algorithm that's running it. And TEs can protect those algorithms, the workloads themselves, and not just the data. And that's one of the really exciting things about this technology. Sometimes we see them as sort of separate to sort of homomorphic encryption or multi-party computation, but actually they're really complementary. Sorry, Ava, you want to say something as well.
Yeah, I want to add that, we've mentioned TPMs and HSMs a little bit, and I think most folks are probably familiar with those. They're pretty widely distributed now. The evolution here is adding more capability, right? TPM or an HSM protects very specific parts of a system, either letting you attest the integrity of hardware components or software components, or protect a key. A TEE protects the entire application and its memory. That's the shift here, and why Sarah gave us in the intro, the consortium spent so much time defining what is a TEE.
And you can write applications to run on HSMs, but it's really difficult. They're really difficult to deploy. It's easy to get it wrong. And TEs are about much more general computation tasks, right?
Mm-hmm. And to your point, to your points about who should care, this also then extends it to the whole developer, anyone who is developing and using data. Oddly enough, that seems to be everybody.
Yep.
Awesome. So we now see a future where everyone needs to think about this. But of course, we don't have a future where all of this technology is evenly distributed. So given there will be a future where confidential computing is widely available, at that point, we hear lots of questions about how much a customer needs to trust their cloud provider. So in the future, when we have confidential computing everywhere, will your customer still have to trust your cloud provider? And how does that really fit? Nelly, I think you were first up on this one.
Absolutely, as cloud provider representative here. So I think this is very complicated and very multifaceted question because it's a question of trust. And again, if I will kind of compare it to our life as consumers, when we're using our ISPs or when we're using our devices, we have to assume that our providers, ISP providers, manufacturers of our devices do their part, do not violate our trust, because otherwise we probably will never use these services. So I think cloud providers today, all of them, Google is not exception, is taking this responsibility very, very seriously and offering services, managed services that will simplify customers' lives with helping them to manage those tremendous workloads they bring into the cloud in the way that it's managed and doesn't require full dependency on cloud provider. But being very realistic and pragmatic as I am, I think even every single confidential computing will be in place. It will be areas when we will remove necessity of trust, but probably still will have some areas that cloud providers would not be able to open source every single line of code that they're using to provide those managed services. So short of this, we do need to provide full transparency on modification, patching, and how those binaries, so these services, these applications that cloud provider offering is maintained, what is the provenance and what is the processes around that. So I think it will be bold that some trust doesn't need to be in place, but I still believe that some areas would require some level of trust. We sometimes internally joking that this concept of zero trust is fantastic dream. But if we will get to absolute trust, with absolute very, very close to zero, we actually celebrate and call this victory. It's my story.
Your thought. Mike, I think you have a slightly different thought on this.
Yeah. So, I mean, I would take it the opposite way around and say that not only should they not need to trust their CSP people, they must not trust their CSP, their cloud provider. When, I'm a big open source person, I think that cloud providers should open source every single piece of what they do, because that's the way we can have the highest trust. And even then, you shouldn't need to. But I want to be a bit nuanced about that. There will always be areas where you need to trust your cloud provider, whether it's to provide, resource availability. That's access to the CPU. It's access to to networking or software storage, whatever. But I think in the context of TEEs, trust execution environments, I want to be removing the requirement to trust the CSP for setting it up and running it. And so that I want there to be no way that the CSP can look at any part of my supply chain, my data, my workload. So I think we come to it from different points of view. I think we're probably hopefully converge on the same answer, but that's kind of where I'd be starting rather than finishing. How's that?
Sounds great. How about you, Ava? You also are part of a cloud service provider. We have two cloud service providers and one open source company now purchased by a cloud service provider.
So it's true. I'm part of a cloud service provider, but I'm also an open source program manager here at Azure. So my role is a lot kind of similar to Mike's, so kind of between the two, like helping the cloud, but also advancing our open source initiatives and building trust with customers through open source. And even long before joining Azure, when I've been involved in open source almost my entire career, probably 15 out of 20 years. And a big chunk of that was working on OpenStack and Kubernetes. So I really agree with Mike. It's possible to have a fully open source cloud stack, even down to open source hardware, open source firmware, open source bootloaders. However, even doing that doesn't entirely solve software security problems. Customers are not necessarily going to read all the source code, and software supply chain attacks against both open source and against hardware are increasing, or at least increasing in awareness, threats. So back to the question, in a perfect world, I don't think a customer would have to trust their cloud provider at all. They'd be able to rely on a third party or independent verification to attest the integrity of the services, detect if the provider was doing anything nefarious or had been compromised in some way. But we live in the real world, and we're not at that ideal state yet. And after spending several years doing bare metal provisioning and bare metal security within cloud providers, trying to ensure that the cloud provider can trust their own hardware, that's hard enough. What we're trying to do now is provide even more on top of that layer of auditability and detectability to compromises and workload isolation. And so while we might have that in some specific cases today, I don't think anyone is fully there yet or where we want to be.
Can I add something to that?
Please do, Nelly.
I think again, and I agree with both of you. I think we've seen that open sourcing everything, it doesn't mean that we provide security. You're absolutely right.
Mm-hmm.
And more than that, we also understand that all our workloads running on silicon and firmware that also has to be validated and ensures that customers trust it. I do believe that in cloud provider world, unilateral cloud ownership will be eliminated. There is a necessity of multiple companies being auditors or being hardware vendors have to collude to somehow expose or leak customers' data. And we want to ensure that unilaterally, based on whatever reasons, none of the companies would have access and control of sensitive customers' data. It's absolute goal across everything. But what I'm trying to be realistic, it's why, again, I started with that. There is definitely time when it will be possible. In some areas and some use cases, we completely eliminate the need of any trust. But still, you have to run on silicon. You have to process this data on silicon. Yeah. And as a result of that, then trust is moving to the areas that even less visible, less open source, etc. So I'm trying to think about that, and I'm sure how everybody in this world trying to think into big concepts. So, and do not overpromise what will not be possible, and trying to say that you have to trust something and somewhere. And that's why zero trust is looking interesting, but it sounds like a little overreaching. So it's again, my opinion on that. I'm sure Mike has something to add.
I wanted to bring out a point you just made, which is that we need to bring out trust. One of the things that worries me even about the phrase zero trust is that there is actually trust in there. I'd like to say explicit trust rather than zero trust.
Yes.
So
Mike, absolutely. Plus one.
But you're pulling out assumptions and you know what's going on. I'm much happier with that as a concept. And you're quite right, Nelly. And Ava, you said similar things.
I would love to echo what Nelly said about zero access, right? We need to get to a state where for specific workloads up to the consumer or the tenant choice, the cloud provider has zero access, even in use. That is absolutely essential for maintaining trust and operating in certain markets.
And understand the decision what they have and who has access. Explicit trust fantastic term.
It
I love
needs
it.
to be programmatic.
And zero access. I think those two, it's what we're going.
Exactly.
It needs to be programmatic. It needs to be business. It needs to be legal. All of those SLAs, all the different layers need to reflect that.
I really want to see us reach the state where our business agreements, right, our trust written in contracts today between providers or custodians of data can actually be encoded in policy and enforced somehow cryptographically or programmatically, not just through a YAML file.
And we know that's difficult.
Yes.
Yeah, we go back to applied cryptography and then practical cryptography.
It's not an easy problem, to be clear, not at all.
We could just talk about this for the entire next hour and a half.
We can occupy this topic.
Move something else.
But I need to bridge to the next question.
yes, Sarah, go.
So I think you're talking about amazing stuff, because trust is the underpinning of this. And we're seeing this inflection point in the industry as the industry moves from a model where our end users and customers didn't have expertise and so wanted to be told, and that trust was then earned through telling people and customers how to manage their fully integrated stack top to bottom, as opposed to what we have now, which is opinions from our end users and composability, because they are the subject matter experts. And so we need them to be just as active in their privacy and their trust engagements with their cloud providers, with their service providers, with everyone. And so in that, we're actually going way back to some of the questions that many of us last looked at in college, but that have been coming up over and over and over, the philosophical questions of ethical and policy in this. So are there ethical and policy implications? And, we've got lots of recent events that bring up security and bring our attention deeply and laser-like to security. How is that influencing this work? What are the policy implications? What are the ethical implications? Ava, I think you were up first.
I think there are definitely both implications and historical things that are informing this work. In the last several years in particular, you mentioned an inflection point. I might point at the Cambridge Analytica incident. There have been others as well. Right? I think we've had a global awakening to the fact that our personal and our private data is in the hands of companies who may or may not be using it in the best interest of those people. And on the other side of the same coin, more companies are prioritizing and investing in or increasing their efforts to protect all personal information, even outside of regulated industries.
Yeah, I'd go beyond just companies. I think we need to talk about governments as well. We're living in a period where the way that we trust governments or don't is changing. We're seeing some possible erosion of civil liberties, even in Western societies, which have historically had, quite strong protections there. And I think we need to be aware that protecting our data as individuals or as companies operating in different jurisdictions and stuff becomes increasingly important. And I think confidential computing is not the answer, but it's part of the jigsaw that can provide an answer as we go through.
I'll jump back in. I would like to get to a place with technology where I, as a consumer of technology, right, I buy a phone, I use a computer, and I travel around the world back in the times when we could, hope to again someday. I'd like to get to the place where I might have some sort of a physical hardware token, like the stuff that is built into my phone, that can protect my data no matter where it moves in the world, right? If it's on a social media site, or if it follows me sort of as a last layer in edge computing for localized translation services, I'd love to see that kind of workload be able to follow me around across providers around the world and still be encrypted back to my token.
So that makes me think of self-sovereign identity.
Yes, exactly.
I was going to say the same
and I think
thing.
one of the interesting things around here is that we've been told with blockchain that there is no need for trust. That's absolutely wrong. Trust needs to be explicit.
Yeah.
And in fact, as we move to more complex blockchain use cases beyond just cryptocurrency and some permission blockchains or shared blockchains, actually there are aspects of that really do need the sort of protections that confidential computing provides. So
Absolutely.
we're aware that it may not be obvious to people from the outside, but those of us who've been involved in the Confidential Computing Consortium, we've spoken to a lot of people from the blockchain community who are saying, actually, this is really interesting. We definitely have ways of using this. We want to know more about it.
Fantastic. I was just going to say, we also need the individual accountability in this trust version, which then we got with self-sovereign identity, which makes me so happy that we had that as a topic. So back to confidential computing as a big picture, as opposed to our specific, how does a customer use it? How does a cloud provider use it? How does an end user use it? What are the use cases there? So big picture, what is one piece of information, or maybe two if you're all moving quickly, that you feel would be essential for someone that is new to confidential computing? Maybe it's a technical tidbit, maybe it's something a little bit longer. What's brand new for someone brand new, what would you like to share with them? Nelly?
One thing about trusted execution environment, I guess, was always gave to normal humans, because it was always part of very technical conversation around trusted platform modules or ARM, TEs, or again, not pointing to ARM by any means, but it was always the kind of, when we talking about TEs, then normal humans started to fade away because it's becoming so complicated so quickly. So my one tip that I would give to every single customer, when you're talking about confidential computing, think about simplicity, think about ease of use, performance, and scale. And it's what we want to bring to our customers. We want to give them opportunity. Do not think about confidential computing, utilizing it very easily for every single thing that they feel uncomfortable to share the data, to share the algos, to share both of them with anyone. It can be cloud providers, it can be hosted environments, it can be, again, social media platform. So there is a necessity for us to think about usability, because without usability, there is no security. So usability, performance, and scale. And I think the goal for us, for Confidential Computing Consortium, to give it all to our customers. It's what we're going after.
Mike, you had a tidbit.
We often say follow the money, right? I watch too many crime programs not to have picked up on that. In this context, I'd say follow the trust. So, what entities, what components need to trust what other pieces of a system to do what? What are those trust relationships? And we need to be clear about those. And what assurances can we gather through to the design or runtime mechanisms that we're using? We haven't talked about a key word actually in confidential computing, which is attestation. So attestation is about how you can gain assurances as to whether what you're doing is what you expect to be doing, running where it should be, et cetera, et cetera, et cetera. So my technical tip is learn about attestation. If you're a low-level person, then learn all the protocol stuff. But if you're not, learn what it can give you and what it can't, how it works for you, how it works against you. Because until you understand attestation, at least at the high level, you can't understand confidential computing.
Ava, thoughts?
Yeah, I kind of mentioned this earlier, but I think the biggest takeaway is that trust today between businesses is represented in contracts, and those often vary between companies. We're assuming that they're actually going to get properly implemented, and this has the opportunity to really change that and to invert our trust model when we are outsourcing computing. That's fundamentally what cloud is, right? You're outsourcing that to somebody else and you're trusting them. This lets us invert that model, but it's not going to be a magic bullet. It's not going to solve all your security problems. Think of this as one more layer of Swiss cheese.
Can I add one additional thing before Mike?
Jump on in.
Sorry.
Before Mike, yes, go Nelly.
On Mike's point, so it's why I'm trying to give him opportunity to answer maybe both. Attestation is absolutely must for confidential computing. Yeah. It's a way how we will prove to you, our consumer or our customer, that you actually running in confidential computing environments. But what I'm also bore you a little bit, attestation, exactly as T was very complicated topic. When we're talking about protocols, when we're talking about claims and all of this wonderful world, it's super confusing. I think we as Confidential Computing Consortium, and we started working on that, we formed specific dedicated SIG attestation to bring usability, to bring clarity to these efforts and help our customers and all of us to arrive to the way how customers would be able to validate confidential computing environments. Because with different silicons, with different platforms, we have different security model for attestation. So it's time for us to figure out how to unify that so our customers don't have to, again, relearn every single variant of that. Back to you, man.
Well,
I'm not going to add anything more. We don't have a huge amount of time. Let's just carry on. You've covered loads of it already.
Ava,
Okay.
did you want to add a bite?
A real quick bite to what Nelly just said, right? We've got the attestation working group in the CCC. There's also a whole bunch of projects in the CNCF that are trying to build in or have already built in TPMs and HSMs. And we'd love to see and collaborate with those projects or others to add TEE support as well. That's all.
Cool. So we've got sort of what we can do today, what you need to learn to get started on this. Now let's jump to the future, because the future is what we all love to look at as technologists. And of course, Ava teased us with confidential computing isn't a silver bullet. So we now know that. So what in 5 to 10 years does confidential computing look like? And what's it not going to solve? Let's see. Eeny, meeny, miny, mo. Why don't we start with Mike?
Yeah, well, flying cars. Flying cars is always the answer to 5-10 years, right? No. Okay.
But is
those.
confidential computing going to make?
No, I don't think so. So, I think that what I hope is that the box that says security, when you're building our application, the box that says security will default to ticked when we're building parts of the system. I think instead of saying, we need to turn on security for this component of a system, we're moving toward a world where developers will be required to explain, to make the case for why they want to turn security off for a particular component. Maybe for performance reasons, whatever it will be. Right. Now, confidential computing won't fix human error, and it doesn't fix the supply chain either, but it does offer the ability, or in the future, it should, to make one or more specific links in that supply chain much, much stronger. And I think that's having it as default is where we want to be.
Ava's up next in our prep, but I know Nelly's going to want to say something in a moment. So does it hold, Nelly?
It will hold. It's definitely will hold.
Right, Ava,
go.
So I really want to sort of double down on the software supply chain comments that Mike was just making. Right, it's a really big initiative. I've been sort of sticking my fingers in the OpenSSF, the Open Source Security Foundation, looking at some of those things. I think, first of all, confidential computing is not going to address that really directly, but it does indirectly through attestation and signing, and the ability to sort of enforce that the application you built has not changed in any way as it moves through different environments. Maybe the container image moves between different registries, is deployed in different environments. Like, if you can enforce that integrity at a hardware level, it helps with software supply chain security. It doesn't solve it. Mm-hmm. So holistic security practices are going to continue to be important, no matter we have flying cars or not. And part of that is ensuring that you have a good diversity program, that all people feel welcome and safe in your company or your project. Because if people don't feel safe to be themselves, that is a security risk. Yep. That's not
to be themselves either. As well as to step up and say there's a problem here. Like, yes. If someone is feeling uncomfortable in an organization, they're less likely to do the right thing, even though they may feel that they need to.
Absolutely.
Nelly, I know you had an opinion about Mike because you were.
I think, again, let's answer your question first,
yeah,
Sarah. In 5 years, I hope it will not take us 10 years, 5 years. We will see that confidential computing will become utility. And what I mean by that every single cloud provider in the world, and I'm sure it will be more than few, will be offering the managed services only and only in confidential environments.
Mm-hmm.
And to accomplish that, we cannot sacrifice in usability scale and performance. And that's what I'm trying to, again, be a little bit more assertive. Performance has to be there. We should be able to demonstrate that performance is not the way why you will disable security. But again, talking back to why confidential computing will be really everywhere. The analogy I will usually use is HTTPS. 5 years ago, we all believed that HTTPS is probably for a few websites because you have to figure out how to deal with PKI and certificate, and who, for the God's sake, will understand PKI. So now, 5 years later, if your website doesn't have certificate and doesn't offer HTTPS, it's becoming the exception from the rule. It's where confidential computing will become. And that's why I act on actually Mike's point that maybe some use cases would not fit. Maybe there is some, again, things that you need to opt out. But by definition, I think 99.99% of customers that occupy cloud and will bring the workloads to the cloud would use confidential computing for every single thing they do. And today's conversation with those customers, and they're asking one basic question: why not?
Mm-hmm.
Is there any reason I don't want to use confidential? And I'm saying there is zero reason. If you can, please do. And it's what we will see in 5 years.
I think that's what makes it different from all of the work I did in previous, like hardware infrastructure security around TPMs and remote boot. The audience for that was so small and the tech was so hard to use. This is so much easier and will be so much more widely available and important.
This has been fantastic. We have like a minute and a half left. Is there one thing that we didn't mention that you leave as an exercise to our readers to go look up?
Yeah,
Mike Bursell.
I've got a quick one, which is that the Confidential Computing Consortium is all of its meetings are open. Come along, whether you're an end user, or you're a techie, you want to get involved in sort of outreach and stuff. It's open. Go to it's confidentialcomputing.io. We'd love to have you. Don't need to pay to be a member, just to attend meetings and have your voice heard. Come along, please. We'd love to see.
Can I add one additional thing, if it's possible, to that? Flying cars. They would need confidential computing.
Yes, we would.
They need to know where to go and process so much data. So forget about that. If you need flying cars, you need confidential computing.
Very good.
I think we end there because we're going to bring flying cars to a secure flying cars, let's be clear, to the world in 5 to 10 years through confidential computing. Have a great rest of the event. Thank you 3 for joining me on this panel. It's been great fun.
Thank you so much.